Hello everyone, welcome back to Wild True Learn. Last time we completed the second section of our game, and looks like we have another story coming up. After the story segment, we are going to move on to genetic algorithms. Let's go. Okay, this bronze, silver, and gold thing, I believe it only affects the story segment. So if you choose gold, you get a story where everything works out really well, you're happy with the results, and you're recognizing the cat properly. And if you choose silver or bronze, then the story is less successful and you don't recognize the cat as well. I believe it only affects the story, it doesn't affect the gameplay in any way. I'm still going to choose gold. So we have neurocomputer vision. It is sorting all the shapes and colors. We have the system set up. Hold still there, science is at work. Is it a cat saying that? Or well, I guess the cat is hooked up. We got a microphone, we got camera, we got electrodes. Maybe that's me telling the cat to do that. Set true predict. Okay, so it looks like it is detecting the cat. You're definitely smiling there. Yeah, it's detecting the cat's emotions, classifying them. Okay, it says that's a smile with 91% accuracy. I'm happy about it. I am nailing it. And to-do list, the cat has been detected. Base cat emotion recognition is also done. So what's our next objective? Goal recognizing cat emotions is complete. Next one is genetic algorithm. Complex emotions recognition. Cat emotions recognition part 2. Okay, I'm out of ideas. Half the time the cat's emotion is recognized as proud and classy. It's the time my cat is usually licking unspeakable parts of its body. I guess it feels real classy while doing so, but what if I'm wrong? Try the genetic algorithm, genes rule. Wait, or was it Jin? Or maybe a genie? Gotta check it out. I'm not really understanding that part. Genetic algorithm is the answer, but you'd need multiple cats to properly train it. Geez, you guys are so stuck in the 80s. Come back when you're sick of waiting for millions of years while natural selection works its magic. Worked with carbon-based life forms, didn't it? Okay, genetic solver in the game. Train model in train run until the evolve button lights up, then click on it. It creates clone with modified error positive or negative. Okay, so here's the error rate again. It looks like it's classifying just by colors. Yeah, because we're getting all sorts of different shapes. It doesn't look like it's doing it by squares. But yeah, anyway, there's the evolve thing. In the real world, one of the most powerful self-learning non-neural algorithms. It simulates biological evolution process, proliferation, mutation, extinction. Only solutions which close to the optimum can survive. Okay, so this is the basic tutorial. I'm assuming we can just hook it up. It's going to be super simple. It just teaches us how to do it. So training. Okay, evolve. Okay, maybe we have to stop it. Okay, evolve. So now we have a new one. This one is already done at 77%. So we throw that away. Train it again. It starts at 77 and goes down to 54. And then we're just gonna keep evolving, I guess. Evolve. Okay, nodes on the field have reached their minimum margin of error. There's nothing more you can teach them. Looks like it achieved the optimum, and then if we run it, it should just work. Yep. Okay, let's do ChessBot. ChessBot for training Kasparov. Hi, as you may know, Kasparov is to compete with AI chess computer next month. Can you write a ChessBot for training? That's kind of ironic. You're going to play with an AI chess computer and then you train against a AI chess computer. Heap news. World Champion versus Genetic Algorithm. One of the greatest chess games of all time, without a doubt, was the battle between Garry Kasparov and the Deep Blue supercomputer by IBM I 1997. The first game was very difficult and tense. Kasparov had an advantage at first, but starting from move 44, many believed that he ceased to understand the logic of the computer, and in the end lost the entire game. You can use custom nodes to make tasks easier. They can include nodes that you have already trained on earlier levels. Yeah, we've seen that before. Okay, red, green, blue. Here we want red and green, red and blue. But since we already have some green and the numbers required aren't even that interesting, we can just send red over here. We can send only green over here. And then only blue over here. Let's do rename. In this task, you need to use one of your previous schemes. Check them out in the custom. Oh, okay. So it doesn't even let me do that. Okay, fine. Pre-trained genetic. This is the one where we had... Yeah, this is the one from the tutorial. Okay, so we're gonna do the same thing. Red, green, blue. Test. Yep. Okay, pretty easy. Hey, have you seen our shop yet? Why earn money if you're not spending money? We've got cool hardware to boost your schemes, new nodes, cat outfits, even an aloe, and much more. You should check out our wares. Yeah, I know that. But we can go and see what's new. We'll filter those. Entourage. Okay. Kindergarten decor. Eternal childhood. Sure. Chair like a boss feel like a boss. Okay, let's look at our chair. Ooh, we got a new chair. This is great. Oh, we can actually type on our keyboard now that we're not here. And then do we have our childhood? Where's the childhood thing? Where is our childhood? Or kindergarten? Is it the wallpaper? I don't see it. Huh. Oh well. Okay, no new nodes. Hardware. NVIDIA increased node work speed by 6%. That's pretty good. Increased node work speed, transfer speed. Okay, and then we don't have enough for that. And then these cats are way too expensive. Alright, let's continue on to the next one. Okay, we got a startup, Evolver. Not even, oh god, okay. Alright, we'll come back to it. Let's try Trajectory Thirst. Good day, I am a representative of McRallen Racing Team. Our pilots are participating in all kinds of races, from rallies to Formula 1. They are doing their best to keep improving their results, and we're there for them too. We want to make a system that will be calculating ideal passage trajectory using machine learning. We were told that you are the specialist capable of carrying out such a task. Alright, so everything except red, everything except green, everything except blue. Accuracy is kind of average. Okay. So we could split it into two and then put these into the right nodes. Wondering if we can do it with just one. So if we do it with just one, we're going to have to sort out the numbers correctly. So we need 30 green or blue. Well, we have 30 blue. That seems okay. 48 red or blue. Okay, we don't have that. So it doesn't look like we... here's a weird idea. I'm gonna connect this first and then explain it later. Okay, so what if our genetic solver is making lots and lots of errors? Let's say it has like 90% error rate. So whatever comes out red is almost certainly not going to be red. It's going to be green or blue. And that satisfies this exactly. And same thing here. Whatever comes out from the green lane is almost certainly not going to be green. And maybe try it. I'm not going to train it. I'm going to assume it starts with a really bad accuracy. 85%, yeah. It looks like our accuracies are doing kind of okay. This one's not doing so good though. Okay, that didn't work, but I thought it was a clever idea. This one didn't quite work because... oh yeah, okay. Probably because there's way more green than anything else. So even if we throw away greens with 85%, or throw away 85% of the greens, even the 15% of greens that remain on this lane is enough to drag the accuracy down compared to the smaller numbers of red and blue. Okay, fine. We'll just do the balancer and then we'll pass it through. Oh yeah, we can use the pre-trained. Pass it through the genetic classifiers, and then we're going to do red, green, blue. I'm going to do that, and then red, second green, second blue. Let's test that. Okay, this one's way too slow. Oh, this one's not even getting enough items. Okay, so we need to put some more red over here. This red is going over here, this red. Let's put that over here, but then this one is only getting green. Okay, we have plenty of green, so I don't think we need to worry about that. Okay, great. Okay, now we should have enough money for Evolver. Hello, we are writing to you from our scientific laboratory. We want to launch a scientific startup. We need a programmer who can write a small part of it, an optimization library which will be using a genetic algorithm. Okay. Okay, we have all sorts of shapes. All the triangles go over here, and then we need different shapes for different colors. Okay, so we're gonna need the colors. Okay, right, we don't have the decision tree anymore. The genetic solver is gonna take care of the colors for us. And this is already pre-trained, so that's cool. And then for each color, we want to sort out the shapes. Well, actually, I wanted to try this one, our new toy. We have a random forest, and what we can do is we have circle, square, and triangle, and if we do this, then all the shapes should be sorted just perfectly along 3 lanes. Now the random forest is slightly slower than Sift, so 1.074 compared to 1.033. It's slightly slower, but if we use the Sift, we're going to need 2 stages. One to filter out all the circles, and then another one to filter out all the squares, or something like that. If we use a random forest, then we get all 3 sorted out at the same time. So let's go red. Red circles need to go here. Red squares we need to trash. And then red triangles can go really anywhere, it doesn't really matter. And then we're gonna do pretty much the same thing for the other colors. So green circles go in the trash, green squares go either way, green triangles go to the bottom, and one more. For blue circles go here, blue squares go in the trash, blue triangles go either way. Okay, let's test that. Yep, looks like it's doing what we want it to do. Let's release. Okay, let's go. Okay, We're losing a little bit of money. Maybe it's just because we need more users to come in. Yeah, there you go. Starting to earn money. Okay, now we have users that are not being served. So let's parallelize this. Try to get it to go faster. Just make a copy paste. Balancer. Also, I wonder, because with these three we did assign them to the first available slot, so like here it's not receiving any of the red triangles, for example. So I'm wondering, so red circle, there's only one place where it can go, but red triangle, instead of coming here, maybe we can make it come over here just to distribute the output load a little bit. Same thing with the green squares, we're going to move to the second option. Green triangle, only one option. Blue, it's the triangles that we move. So let's test that. Okay, we're still doing good. Patch. Okay, now we should be... Okay, now we're earning a lot more money and we're serving all the customers. Oh, we got even more customers coming in. Okay, I kind of doubt it's going to let us do another layer of balancers. Yeah, because in our past experience, every time we put like 3 balancers up front to divide into 4 lanes, it ended up being a lot slower. Sorry, not slower, but ended up costing a lot more. So I don't really think this is going to work. But we'll just test it for a day. Okay, we're making a little bit of money. Okay, we are making a little bit of money, but it's significantly less than what we were getting before. So yeah, still not a good idea. Okay, I think this is how it was before. Let's just test that. Yeah. Okay, let's just go. Yeah, we're making significantly more money now. Okay, and then we'll just keep going, I guess, until the users die down. Okay, this one just keeps going. Wow. Still getting tons. Okay, now it's starting to die down just a little bit. Okay, looks like we're near our limit now. 3. I don't know if we're going to be positive by the end of this week, though. Just a little bit. Okay. Now it's definitely time to cash out. Holy cow, 16,000. Yeah, sell. Okay, let's see if there's anything we can buy. We can buy the 17,000 cat. Or we can buy 16 gigabytes of RAM. I think I'm gonna get the cat first. Tank cat. The cat is not sleeping, it's preparing to attack. It could be both. If you know cats, they can be preparing to attack in their sleep. Oh, we haven't looked at the cats yet, yeah. He's carrying a tank shell, that's great. Okay. Let's go to coffee machines. Automatic coffee machines. Greetings. Our company, Robo Coffee, is famous for its automated coffee machines. We want our coffee to be as exquisite as famous Italian brews, but we're not quite there yet. Maybe a computer algorithm could help us master our recipes. Of course, mistakes will be made, but we're sure that something good will come out of it in the end. Okay, this one, everything else can accept everything, but this one doesn't want any red. Okay. We can do genetic solver. Let's just try balancing the numbers and see what we get. This one only needs 30 green and blue. So pretty much if we just stuff all the blue in here, it'll be enough. But I think, let's see the number. 30, 72, 100, and 252. This one is 105. 150, 205. So yeah, we can afford to put a little bit more. Yeah. We're gonna use the pre-trained so we don't have to train it again. Okay, red goes, let's put it in here first. Green and blue we're gonna put in here so that we have 50 out of 30 required. And then the other one, we're going to do, this one requires 72, and it currently has 55. So 55 plus 25 is 80. 80 out of 72 should be good enough. And then we have 75 out of 50. Let's test that. Okay, it seems to be fine, just too slow. Alright. Well, we know what to do about that. Oops. Copy, paste. Balancer. Another balancer. Okay, done. And let's do one more mission. Prediction of winnings. Prediction of winnings in a casino. Hello there, you know I'm a big gambler. I'm going to Vegas next week and hopefully I'll make some money. Did I say some? I meant to say huge money. I need you to write some code or whatever you do there and predict all the ways to win in roulette. If you do everything right, 5% of my score is yours. Please find some related data enclosed. Yeah, you know, I can predict. I can predict you'll lose huge money. If you want to win huge money, why don't you learn how to do machine learning and then you do the startups. Okay, output stream 1. They only take red. This one needs twice as many, but even 16 is nothing compared to the 60 red that we have. So what's the trick here? Why is this a thing? Red, I'm gonna put the red over here. I'm gonna trash everything else. Test. Oh, no. I keep doing that. Okay, we don't want to train. Okay, red. Trash everything else. Okay, it's just too slow. Okay, this one only requires 60% accuracy, so if we do like green and red, if we put one more color in here, then it should be about 66% accuracy, which is still good enough for the Yeah, this is another situation where you just completely cheese the thing by adding items that you know are wrong. As I said before, this isn't really realistic, but it's a game mechanic, so I'm gonna be okay with that. Alright. I think that's it for this episode. Next time when we come back, we're gonna do both of these reinforcement learning tasks, which I believe are more interesting and will be longer. So that's why I didn't do them today, but we'll do them next time. As always, hope you enjoyed. See you next time.